Alright, hi, from www.survivalebooks.com. This was downloaded. Alright, this is Subcourse OD1004 Edition 6, U.S. Army Warrant Center and School Wheeled Vehicles and Fuel and Exhaust Systems. Alright, U.S. Army Light Wheel Vehicle Mechanic Lamar 63B, Skill Level 3 Course Vehicle Fuel and Exhaust Systems, Subcourse number 0OD1004, Edition 6, 5 credit hours. Wheeled Vehicle Fuel Exhaust System, Subcourse Light Wheel Vehicle MOS 63B, Skill Level. Course designed to teach knowledge necessary to develop the skills and equip to maintain fuel exhaust systems. The subcourse provides about fuel and exhaust system, both spark and ignition, compression, ignition engines. It also provides information inspection procedure for these systems, and subcourse is provided in 3 lessons, or each lesson concerned is a terminal objective as indicated below. Lesson 1, Fundamental Gasoline Engine Fuel Systems. Describe fundamental gasoline engine fuel system. Give information, type, location, operation, inspection, gasoline engine, fuel, and air system. Lesson 2, Fundamental Compression Ignition Engine Fuel Systems. Describe the fundamental compression engine ignition engine fuel systems. Give the information with the type of location, operation, inspection for the compression ignition engine fuel system components. Lesson 3, Engine Exhaust System. Describe the fundamental engine exhaust system. Give information about location, purpose, construction, inspection, and engine exhaust systems. Alright, table title, page, table contents, introduction, wheel, vehicle, exhaust systems, fundamental gasoline engine fuel system, learning event 1, describe the components of the gas engine fuel system, describe the principles of the operation, carburetors, 3, define the description, procedure for inspection, gasoline engine fuel system, lesson 2, fundamental compression ignition system, learning event 1, describe the components and principle operation, fuel injection system, learning event 2, describe the principle operation, compression ignition, engine air introduction system, learning event 3, describe the procedure, inspection, compression ignition, engine fuel system. Learning lesson 3, engine exhaust system. Learning event, describe the components of construction, inspection, exhaust system. Alright, your introduction. Introduction, wheel, vehicles, fuel, and exhaust system. Then jump the fuel system, same with the correct fuel, air, mixture, the engine, all time, but the content of the mixture and amount of the mixture must be variable to meet the ever-changing need of the engine. Over the years, there's a lot of research equipment that have developed the present-day fuel system. This system must be serviced and maintained properly. It will not work, or it will not work as it should. The combustion burning is the fuel of the air engine, included with several chemical changes. For example, each gallon of gasoline is burned out. 1 gallon of water is produced from a form of steam. Anything that is formed in carbon monoxide colors odorless, deadly, and poisonous gas. Exhaust strokes rid the engine most of the combustion procedure. The exhaust system takes exhaust fumes away from the engine, cuts down the noise, gets rid of gas. None of these carbon monoxide reaches the people in the vehicle. For safety of the personnel and proper maintenance of the exhaust system, it must, as is a must. The purpose for the system to give the knowledge, develop the skills, serve to maintain fuel exhaust system. Lesson 1, in fundamental gasoline engine fuel systems, describe fundamental gasoline fuel systems, given the information, type of the locations, operation, inspection, gasoline engine fuel, air system components. Reference TM 98000. Learning event 1, describe the components of gasoline engine fuel systems. Alright, lesson event 1. Describe the components of the gasoline engine fuel system. The primary job of the fuel system is to provide the correct fuel air mixture for the engine cylinders. To do this job, the system must have the components of the stored fuel, reprove impurities, send the fuel to the fuel and air mixture, and make a meter of the mixture, send it to the separate cylinders. Some of the components of the fuel system require the precise adjustment. All of them require maintenance with the care. It is necessary for the wheel vehicle mechanic to understand how each of the fuel system components work. Although the location components of the wheel vehicle may vary, each fuel system contains the same components. Fuel tanks. Fuel is stored in fuel tanks. Location fuel is not important. Heavy trucks must have fuel tanks mounted in the front of the rear wheels. Sometimes it will locate underneath the driver's seat. Most of the fuel tanks are made with thin steel sheet or plastic. These same steel sheets are crimpled, welded, and have to take leak-proof. Tank is coated inside and outside to prevent rust. The coating is called the turnoplate and alloy or tin lead component. Typical fuel tank. Fuel funnel shape with the fits inside of the filler neck of the military vehicle with the train or with the gasoline before it enters the tank. Screens are not used with the fuel tank. Civilian vehicle with these screens are easily removed for cleaning. On military vehicle, fuel tank cap seal with the filler neck will probably be tightened. Military vehicles must be able to forward body with the filler neck of the other openings in the tank of the water pipe. Show the fill pipe fuel gauge opening ridges of strength, baffle passages for fuel transfer, drain plug, fuel outlet. The drain plug screws with the thread hole with the sum of the lowest point of the tank of the drain plug can be removed, flush out any water, foreign substances, trash that might get in the tank. Some of the tanks have baffle plating strength with the tank to reduce the sloshing of the fuel with the rough roads. Fuel sloshing with the tank creates problems. The first fuel evaporates rapidly and sloshes around in the container with especially hot weather. Also, sloshing fuel generates a static electricity sparking in the fuel tank condition and an explosion baffles control of liquid. Still, all the fuel will move freely through the perforations. An outlet pipe with a pickup pipe is installed with the top of in the side of the fuel tank with the bottom tip of the pipe at the position with a half inch above the bottom of the tank. Reduces change of the pickup of the water trash. Sometimes tip at the end of the pipe the shield with the screen and filter to keep the trash entering. Vent tube is necessary for the outside and air with the can fill up the space left with the fuel drum. With the tank of the vent space allow the air tank to escape. The fuel with the tank expand. But the fuel always expands when the vehicle is standing in the hot sun. A military vehicle with the vent is leak-proof through the contents of the tank of the carburetor, air cleaner. Sometimes the fuel pickup and the vent tubes are placed together. The vent tube is smaller than the fuel pickup tube. A fuel gauge is sending unit is connected with the electrical wire. The fuel gauge of the vehicle instrument panel with the sending unit shall have the level of fuel in the tank. Your main fuel line. Fuel from the tank is delivered to the engine by the main fuel line, usually made with copper or steel tubing secured with the frame with the clamp clips with the reduced chance of breakage. An engine with the compartment of flexible hose can contend with the main fuel line with a filter with a fuel pump. Without this, the flexible hose main line fuel line would be broken and vibration begin engine and frame. Fuel filters. Filters used to remove the trash could hurt engine performance and clog fuel passes. Carburetor contains many small passages that can easily be clogged by trash. For this reason, fuel filters are located between the fuel tank outlet pipe and carburetor. Some vehicles have more than one filter. Filters may have the metal screen sediment bowl in common use but nowadays filters are often made with a bleeded paper and disposable. Fuel pumps drum the fuel for the tank delivery with the carburetor. The pump delivers right with the amount of the fluid. Fuel the engine operation both light and heavy loads. In addition, pressurizing fuel line between the carburetor and pump. The pressure reduces the possibility of fuel vaporizing, boiling because of heat from the engine. Fuel for the pump is generally classified as either positive or non-positive. Positive type of the fuel pumps fuel continuously while the engine is running must have some means of returning fuel, but the engine does not use vehicle with a positive fuel pump pass excess fuel back to the fuel tank inlet side of the fuel pump. Non-positive type pumps supply fuel only when it is needed. Fuel pumps are widely used with the wheel vehicle with gasoline engines. Non-positive diaphragm type with the type of the pump is usually operated mechanically with the engine. Diaphragm type fuel pumps. Operating linkage pump consists of the rocker arm, link, and spring with a flexible diaphragm with the hooked with the link with the rod. Diaphragm is clamped at the outer edge of the two halves of the pipe body of the pumping chamber. There's area between the diaphragm and the valve assembly. Fuel pump is mounted with the engine with the rocker arm contact with the eccentric of the engine camshaft. The eccentric turns force of the rocker arm link the pivot turn on its pin and pull the diaphragm down. The downward movement of the diaphragm compresses the diaphragm spring and enlarges the pumping chamber to create the low pressure or vacuum suction in this pumping chamber. In the meantime, air entering the fuel tank vent atmospheric is pressing down on the fuel tank. Pressure forces the fuel flow from the tank through the line, through the pump, and the valve into low pressure area with the pumping chamber. Remember, the liquids and gases will always flow high pressure area to low pressure area. Figure 2 shows the diaphragm of fuel pump. Show the piston chamber, the check inlet, outlet valve, outlet check valve, pump diaphragm, diaphragm spring, rocker arm, vent hole, oil seal, pull rod, rocker arm, camshaft lobe. When a camshaft eccentric rotates 180 degrees, no longer pushes the rocker arm down. The rocker arm spring then forces the rocker arm to pivot and pins the opposite direction. Press the diaphragm spring now pushes and putting the pressure in the fuel pumping chamber. Pressure created by the diaphragm spring closes the inlet valve, forces the outlet valve of the carburetor. Diaphragm moves up and down manner whether the carburetor bowl is filled with fuel. Alright, with carburetor bowls filled, the needle valve blocks the fuel flow. This causes back pressure for the fuel discharge in the pumping chamber of the fuel pump. The diaphragm now has a fuel back pressure top of the diaphragm spring below. If the fuel pressure is the same if the compressed spring of the diaphragm will stop at the intake down at the time of the rocker arm and still pivoted up in the down following the camshaft eccentric. However, the rocker arm will no longer move with the link because of the two separate pieces of the rocker arm move with the link of the down can never push it back up. When the carburetor needs more fuel, the needle valve of the carburetor opens, the back pressure discharge line is relieved. Allow the diaphragm spring to push the diaphragm up, forcing more fuel for the carburetor pass. Open needle valve of the eccentric in the cam rotates the valve of the diaphragm to pull down again. Pumping is resumed. Electrical fuel pump. The two types of electrical fuel pumps used in military wheeled vehicles. These pumps are operated by either electric motor or solenoid. Alright, this shows your bellow type electrical fuel pump. It shows the outlet valve, bellows, armature, electromagnetic coil, contact points, outlet, stroke, return spring. Alright, electric bellow type. The bellow type is electric fuel pump will basically work like a non-positive mechanical pump. The difference of the drawing with the electrical cylinder rather than mechanical camshaft. Operation is valves electric eccentric with the current is fed with the pump with electromagnetic coils pulls the armature down, expanding with the bellow. The expansion of the bellow is caused with the fuel to draw in through the inlet valve. As the bellow fully expands, the pair contacts the open switching of the electromagnet, the return spring with the pressure of the armature back with the contact valve with the action pushes the fuel out of the pump through the outlet valve. The contact points over the bellow fully contact track the cause of the electromagnetic to pull the armature down, repeating the pulling process. Pump will stop the fuel pressure high enough to the bellows expand against the return spring with the operating pressure of the pump determined with the return spring pressure. This is a vane type electrical pump, power lead outside, fuel inlet, and fuel discharge port. The vane type integral seal rotor end shaft at one end support with the pump flange over the end with the cover of the resolve with the body. The bore of the body eccentric with the rotor with the slide vanes 180 degrees apart with the rotor pressed against the body with the shore with the spring with the slots when the shaft is to rotate with the vanes pick up with the inlet port carrying it around both body outlet side with the fuel with the discharge pressure reduce the welding action. Wedging action with the fuel is forced toward the outlet port by the vane. Air filters. A mixture of fuel air burn in the engine cylinder during the power stroke. The mixture of the fuel air is in function of the carburetor, air cleaner, internal combustion engine serves as three purposes. In filters, air remove the dust and dirt before it enters the carburetor. This is very important because the engine requires about 9,000 gallons of clean air for every gallon of fuel that it burns. And it acts as a flame arrestor to prevent fires in case the engine backfires. It acts as a muffler, reducing hissing noises made in entering the carburetor at a high speed. Air cleaners are generally classified either wet or dry, depending on what method is used for the filter of the air. Alright, figure 5 shows a wet type air filter. So, shows the cover main body oil reservoir, oil in black, and then unfiltered air, filtered air. Cover main body oil reserve filter element. The wet type is usually called the oil bath air cleaner. All air enters the filter with the top or edge of the flows from the side over the bath oil with the reserve of the direction and moves over the filter element to the carburetor. How the heavier dust is separated with the air passes the oil bath and suddenly change with the direction moving over the down to help heavier dust practice with the continue move down with the trapped in oil. Later particles trapped in metal gauze filter element as airflow reserve the direction of the oil reservoir picks up the oil mist of the oil bath to keep the filter element soaked. This shows your dry type air cleaner. Filtered air enters the carburetor. Filter traps foreign matter. Spotted unfiltered air clean. Filter air enters filter. Some dry type air cleaners are used the metal gauze and paper filter element. One of the essential figure on aerosol principles is swirling motion, sudden change of the direction of airflow separates the dust from the air. Most dry filters used today replace paper element. All filter elements other than the chamber around the filter element then filter through the small holes ultimately entering the carburetor. Alright, learning event 2. Describe the principal operation of the carburetor. Vaporization. Liquid fuel sent from the fuel tank with the carburetor properly burned with the gasoline through the mixed air. The gasoline may be vaporized with the liquid chamber. The vapor that evaporates in the air with the boiling water. Example of vaporization. As water boils to steam, steam is made liquid in very small particles. With the tiny particles of vapor mixed with the surrounding air. Several things different, however, easily liquid will vaporize. The nature of the liquid itself is one factor, for instance, well known for that alcohol, which is lighter than water, vaporizes more easily than water. Gasoline, which is lighter than water, vaporizes easily than water. Second factor controlling vaporization temperature. High temperature, each case the liquid vaporizes faster. Example, the water turning steam is boiled. Another factor controlling vaporization is the amount of vaporized liquid already in the air. Humidity. You can understand that the thinking of the air is a sponge. When a dry sponge is placed in a pan of water, it soaks up and absorbs a large amount of the water very rapidly. But the sponge begins to fill, it absorbs the water more slowly. Finally, it reaches a point where they will still not absorb any water at all. Air acts as in the same manner here. When you hear a weatherman say humidity is 100%, this means the air has stoked up all the moisture and can hold that temperature. Figure 7 shows the example of atomization, liquid broken into tiny particles. Liquid can be made and vaporized more rapidly, breaking into small drops. They can be done in an ordinary spray gun, breaking liquid with small dots, called atomizing liquid. When liquid atomized with the ground with small drops, more of the liquid is able to come in contact with the air in one time. Liquid vaporizer faster. Gasoline is not vaporized does not burn. Only vapors burn. All fuels and engine cylinders should be burned before end of the power stroke. This fuel still liquid is wasted. Fuel is left in the combustion chamber will discharge the engine exhaust system. Some of it may go in piston, go past the piston and the crankcase mixed with the oil, and then this can cause damage to the engine bearings. Because gasoline will dilute the oil. Our gasoline fuels blend mixture with the refined crude oil, perhaps the mixed vapor mixture of the low temperatures cold engine starting. Others may sure vaporize better in engine warm up. High volatile, easily vaporized gasoline will burn quickly. Fuel burning rate slowed down by another substance with its power of the fuel mixture, such as tetraethyl lead. The fuel burns rapidly with the engine power released very suddenly, like striking the top on the piston with a hammer. The vibration caused the fuel burning to fast and causing the engine ping. Sharp hammering noise of the engine. Engine ping, if allowed to continue, will damage engine parts. Octane numbers are assigned with the different grades of gasoline. The number tells how fast it will burn, and the octane rate gasoline mixture is determined by laboratory methods. Low burning blends have higher ratings. For example, the fuel with the octane rating of 80 will burn more slowly than one with an octane rating of 70. Vaporization fuel gasoline starts in the carburetor. Continued fuel pass through the intake manifold, even after it enters the cylinder. Principle of entry action. The main job of the carburetor is to supply with the right mixture air fuel with any of all speeds, location, and load conditions. Understand how the carburetor does this necessary to understand the principle of entry. Your venturi effect shows the air horn discharge venturi. Air speeds up with the corresponding pressure drop. Atmospheric pressure fuel out of the discharge nozzle, fuel and fuel air mixture. The venturi has an hourglass shape of the airflow with the color of the throat-bore barrel and carburetor. Normally, the air flows rapidly with the throat of the carburetor way to the engine with the cylinder of the fastman with the reach of the venturi with the must be up through the restriction. When the airspeed increases the venturi with how there's a drop in the air pressure, the faster the air moves with the pressure drop. Principle also applied with the nozzle water hose. The nozzle itself, the restriction water speed, the increase of the level leaves the hose end passes through the nozzle. This is why the steam of the water leaving the nozzle travels farther than the air does when the no nozzle on the hose. The important thing to remember venturi is that increase the speed of flow there is to decrease the pressure air entering the air horn mouth of the carburetor is 14.7 pounds per square inch. Normal atmospheric air pressure at sea level. Alright, your carburetor components. The simple carburetor gasoline store with the float bowl with the passenger bottom of the float bowl leads to the discharge nozzle located in the center of the venturi of the engine running of the engine, and each piston acts like the engine air pump during its intake stroke. Low pressure air vacuum created by the engine cylinder outside. The air rushes through the carburetor board to the lowest pressure area above the piston. Atmospheric pressure pushing down the fuel in the float bulb. The discharge nozzle entry is above the level of the fuel in the bulb. The rushing through the venturi creates low pressure area at the tip of the nozzle. Atmospheric pressure of the fuel in the bulb pushes the fuel out of the tip of the nozzle. Gasoline leaves the nozzle, entering the airstream is broken into small drops atomized by the fastly moving air. The amount of air mixed for each for the fuel is called the air-fuel ratio. Air-fuel ratio, weight of one part mixture compared with the other parts in pounds. For example, 15 pounds of air mixed with 1 pound of fuel is an air ratio of 15 to 1. Mixtures are made with the rich, adding more fuel or removing some air. Air-fuel ratio, average engine rating, operating normal cruising speed at 15 to 1. When more power is needed with the engine idle reacher, mixture of 13 to 1, 12 to 1 is required. Alright, figure 9 shows the throttle valve assembly. Accelerator pedal operates the valve. The idle stop screw throttle valve regulates the mixture of the engine. Alright, probably the most important control of the carburetor device to change the amount of fuel mixture is going to the engine with the control. There would be no way to change the engine speed with this control device. The throttle fuel assembly, which is round with a flat disc mount on the shaft of the throttle valve, is a shaft near the bottom of the carburetor bore with the path of the airflow. The throttle valve is connected with the linkage accelerator pedal with the driving compartment. Accelerator pedal is pushed all the way down when the throttle valve is wide open. Air fuel mixtures freely with the valve. The engine can produce the greatest power speed. Engine idle speed of the valve is almost closed and only a small amount of the air is passed through the valve. Carburetor circuit. Most of the carburetor circuits have 5 circuits. Passive fuel flow with the venturi. Other points for the carburetor bore. The circuits may necessarily different engine speed. Operating conditions require different fuel air mixtures. The 5 carburetor circuits are float circuit, low speed circuit, high speed circuit, accelerating pump circuit, and choke circuit. The fuel of the carburetor bowl must be kept certain level when the engine is running. The level too high with much fuel discharge with the nozzle. Engine will have used too much fuel. Large deposit carbons must form in the cylinder. The fuel level low mixture will be too lean to operate the engine properly. Float circuit will keep the fuel at a correct level. So this shows your figure 10 float circuit with the needle valve, fuel inlet pivot, and the float fuel and air mixture. The float consists of the float hinge on one side of the carburetor bowl position so that it will operate the needle valve open and close the fuel inlet. And for fuel under pressure of the fuel pump enters the carburetor bowl at the fuel inlet. When the fuel enters faster, the engine can use it. The bowl fills up. The cause of the float to rise and push the needle valve within its seat, shutting off the incoming fuel. The engine is fuel, and fuel level. The bowl drops. The float lowers. The needle valve opens. More fuel is allowed to enter. In actual operation, needle valve is very seldom. Instead, it stays open just enough so that the balance of the maintaining fuel coming in the bowl, fuel is used in the engine. Figure 11 shows the controlling fuel bowl pressure, balance tube equalization pressure, float over the air horn, ideal vent operated throttle linkage fuel. A very located top carburetor. The vent is neat with the air pressure all present with the fuel of the carburetor bowl. On military vehicles, the vent is used to connect the inside of the carburetor air horn with the air cleaner. While the throttle is almost closed, the amount of the air flowing with the carburetor bore is small, with practically no vacuum created with the venturi. There is no flows with the nozzle from the venturi. Low speed circuit supplies fuel under this condition. When the throttle is closed, the engine creates a high vacuum bellow with the throat valve between the valve itself with a restriction as it acts as a restriction. Low speed circuit is as an idle discharge hole below the throttle valve with a higher air pressure for the fuel. Carburetor bowl push for the fuel to the vacuum idle discharge hole. Small air bleed located at the top of the low speed circuit passage with the air bleed is a circuit mixture with the gasoline help atomize the fuel before it leaves the idle discharge port. Just the needle valve displayed with the idle discharge hole with the turning of the screw changes the richness of the idle mixture. Turn the screw inward to close the hole allows the less fuel to flow. With less fuel flowing, the linear mixture is created. With screw in the turnaround, the more fuel flows, the mixture is richer. Opening the throttle a little above the idle speed allows more air to pass the throttle valve. However, there is still enough of the air passing through the venturi to get the fuel flow through the main discharge nozzle. The more air passing through the valve, some of the more fuel that must be added to keep the mixture correct. So let more of the air low-speed discharge in just above the idle discharging hole. Throttle is open slightly with the edges moved above the low-speed discharge hole. More fuel enters the airstream because it can pass through the two discharge holes. In some carburetors, low discharge slot is used instead of holes. Alright, the high-speed circuit includes the venturi with the main nozzle of the high-speed jet with usually more than one venturi with an U in the carburetor with one placed inside of the other. The main nozzle center and the smallest venturi with the fuel pass with the carburetor bowl with the main nozzle flow with the high-speed jet. The hole in the jet drilled exact side of the metering flow, fuel flowing with a high-speed circuit. Operating high and low-speed circuit, the overlap of the throttle is moved. Each circuit continues working after and the next one begins. If there's no overlap between the circuit, the engine will run rough and even try to stop a certain throttle position. This condition is called flat spot in a carburetor. Alright, when the engine is operating with a cruising speed with the air-fuel mixture that's about 15 to 1, but being furnished with a good, economically reasonable power with the power system of the high-speed circuit with a candy wrench, the mixture necessary to climb the hill with the operate high speed. The two types of power systems commonly used with the power jet and the metering rod. In the power jet, with the power jet valve is controlled with the vacuum piston, the throttle is closed with the main manifold vacuum is high with the vacuum piston is moved up against the spring pressure. The power jet valve is closed, opening the throttle at the point which more fuel is required lower in the manifold vacuum. Low vacuum allow the piston to be pulled down by a spring pressure. This opens the power jet valve, letting the fuel flow through a power jet. The fuel must bypass the high-speed jet, increase the amount of fuel that is delivered with the airstream main discharge nozzle. Metering rods. Another way to enrich the fuel-air ratio to get more power. The metering rod is used for the operator linkage connected with the throttle valve. The rod is several steps or tapers on the lower end of that pass of the high-speed jet. As the throttle opens, the rod is lifted to smaller steps are the jet. This allows the more fuel pass through the jet enriching mixture. Alright, assume that the vehicle is moving down road slowly. The throttle valve is particularly closed, allowing only a small amount of the air to pass through the carburetor vent for the driver. Suddenly, it decides to pass a car ahead, slams on the accelerator pedal to the floor. The throttle valve opens instantly. Very little weight is so that increases speed through the carburetor very quickly. How much fuel is much heavier and it will move slowly, but the fuel and air flows become balanced and the very lean mixture delivers to the engine. Discover the engine and backfire hesitate. To prevent the backfire hesitation, the carburetor is equipped with an accelerator pump circuit. The circuit discharges a small amount of fuel into the airstream for a very short period of time when the throttle is suddenly open. The type of the accelerating pump consists of the pump cylinder, pump piston is operated with the linkage connected with the throttle shaft, fuel intake check valve on the bottom of the pump cylinder, or well pump discharge check valve, pump discharge nozzle, spray fuel into the airstream into the carburetor. Alright, when the throttle is closed, the accelerator piston is moved up. The position the throttle is open, the piston moves down with pressurizing fuel. When the pump cylinder pump intake check valve closes, the pump fuel pump well is forced into the pump discharge valve of the pump nozzle of the carburetor bore. If the pump is moved down suddenly, the fuel cannot immediately discharge through the small discharge nozzle. For this reason, the operating change linkage does not push directly on the discharge piston. Instead, the down the action pump allows the fuel flow through the pump discharge nozzle. Several second discharge tapers of the movement of the fuel with the main metering circuit. Increase with the accelerating pump circuit refill of the fuel with the throttle close. The down and upward movement of the piston pump intake check valves permit fuel from the carburetor bolt to enter the pump cylinder. Other accelerating pump circuits are operated different. One type of the manifold vacuum spring pressure to operate the pump. Another type of the pocket air between the piston and fuel eliminate the need for the accelerating pump spring. It is a well-known fact that the richer mixture is needed for the engine is cold because of the fuel is supplied with the cylinders will not vaporize when cold. Therefore, a larger amount of fuel must be supplied to get enough vaporized fuel in for combustion. To supply extra fuel, a choke circuit is used. The choke is round and flat disc, similar to the throttle valve of the carburetor. Air horn above the venturi, closing the check valve creates the high vacuum sensor carburetor throat. This closes with large amounts of fuel flow freely from the bottom of the low and high speed. Chokes may operate manually by a driver, or they may operate automatically. To operate a manual choke, the driver usually pulls a cable, closes the choke valve. Closing the valve completely shuts off the supply air. However, the gasoline must have some air in order to burn. The needed air is emitted by one of two methods. One method is the choke valve that includes a spring-loaded poppet valve. The poppet is normally held within closed position with a weak spring. As soon as engine is cranked with a very high vacuum is created under the choke valve. This allows with a higher outside air pressure to open the poppet valve and permit the air enter the engine cylinder. Manual method choke valve is operated with a coil spring on the choke shaft. The choke shaft is closed with the engine cranking an engine. Air pressure will overcome the spring tension, opening the choke valve slowly. Some of the air supply some air. As the engine warms up, the driver gradually opens the choke to supply a leaner mixture. The automatic choke controls the air-fuel mixture for quick starting at any temperature. Addition with the provided with the power mount choking during the entire engine warm-up. The automatic choke with the thermostatic spring with a vacuum piston with control of the piston with the choke valve. The spring type of the choke will close the choke valve when the engine is cold. When the vacuum piston drive to open the valve, the choke valve is mounted off-center on its shaft, increasing the air speed and aids of the opening of the choke valve more. Operating automatic choke depends on the three factors: temperature, intake manifold, vacuum, speed of air passing through the carburetor throat. Temperature change with the thermostatic spring. When the spring is heated, the loss loses the tension, allowing the choke to open. When the engine is cold, the spring holds the choke valve closed. The engine start vacuum below the throttle level, the directed bottom of the vacuum piston. High vacuum under the piston causes the piston to work against the spring pressure partly on the choke. Partially open the choke. A small amount of air heated with the engine exhaust passes the choke housing with a heat spring, allowing the choke to open. Engine warms up. During different load conditions will also cause the position of the choke valve to change. Decrease the manifold vacuum, allow the spring to close to the choke against pressure vacuum piston. Increase the air speed through the carburetor throat will force the choke valve to open against the tension of the spring. Alright, multi-barrel carburetors. Many multi-barrel carburetors, particularly with engines of more than 6 cylinders, have more than one barrel. Each of the barrels, 2-barrel carburetors separated low and high speed. The carburetor has 4 barrels. At least 2 barrels will have low-speed circuit with the accelerating pump and with the separate throttle valves. Each of the pair will the 2 valves are mounted with the same throttle shaft, causing the throttle valves to open and close at the same time. The purpose of more than one barrel is to split the air-fuel mixture delivery with the different cylinders between the same independent carburetors. For instance, consider the 8-cylinder with the V-type engine, the 2-barrel carburetor. 1 barrel will take care of the 2 middle cylinders, the left bank, and the 2 end cylinders on the right bank. The other barrel will take care of the remaining 4 cylinders, which in an arrangement intake manifold divided into 2 sections, with each section delivered in fuel air mixture 4 cylinders. Carburetors are also classified updraft, downdraft, and side draft depending on the carburetor position. Respect with the intake manifold. Carburetor is mounted below the manifold, classified as an updraft carburetor. If above the manifold is the downdraft. When the carburetor and intake manifolds are the same level, the carburetor is side draft. Alright, intake manifold. With the gasoline vaporized rapidly with the natural refrigeration cooling process takes place with the fuel with the outside of the carburetor throttle housing. When the engine is running, housing feels cool, though all the surrounding parts very warm. The expansion of the frost often collects around the carburetor intake manifold during the cold weather. The cooling action may cause fuel vapors to condense into liquid drops. Careful construction design manifold reduces condensation. Intake manifold should be as short and straight as possible to reduce possibility of fuel condensing before it reaches cylinder to assist vaporizing fuel. Some intake manifolds have sectioned hot spot that is heated with exhaust gases. A valve is placed in the exhaust manifold that directs the flow of the exhaust gas to the hot spot. Thermostatic spring control for the operating of the valve. The engine is cold. The valve direct gases to the hot spot. As the engine warms up, the thermostatic spring loses tension, and the gas pressure is aided in weight and turns the valve of the hot gas down to enter manifold hot spot. On some vehicles, the heat control valve does not have a thermostatic spring. In this case, the valve is manual set on off, intermediate, and on position depending on the weather operating condition. Another method is to circulate engine coolant around the manifold hot spot. The hot liquid instead of the exhaust gases heats the intake manifold. Alright, learning event 3. Describe the procedure inspecting gas engine fuel. To fuel system, only one person is provided with the proper air fixture measure with the proper amount with the proper plate with the proper time. Each component of the system has to operating properly with the fuel system to do its job. The weather, the wheel, vehicle, mechanical fit into the picture. Your job of the fuel system will consist in ensuring that each of the components is doing its job. To do this, we'll have to know how to clean, tighten, test, adjust, repair, replace fuel system components of gasoline engines. fuel systems, which are not going to uncover inspection of these parts of the contents less an example of the job unit maintenance will do. Keep in mind when you're working with the fuel system, the gasoline made to burn engine is not on it. Neither should it burn in the tank, on the floor, or on you. Make sure your work area is kept free of spilled gasoline. There are no sparks and fire in the area. If inspecting fuel system, before any work is done with the fuel system, you must know what needs to be done. On way to find out inspection, this means looking over, seeing if you find anything wrong when inspecting. You start at one end of the system, either end, and work step all the way through. Do not miss a thing. We'll miss the fuel tank on a quarter-ton M151. The first thing is you see on the filler neck cap is that. So let's take it off and get a good look at it. Two things you should look at is dirt and rust. Neither of these should be in. Give it a chance of the fuel tank, because they can cause a lot of trouble. In fact, they probably cause more fuel system trouble than anything else except the possible water and any other. To look over the cap, retaining chain which keeps the cap from the drop and lost, and also gasket in the cap must be good sealed between the cap and the filler neck. Alright, inspect the trainer inside the filler neck. It should be free of the rust and dirt, with no holes, bends, or kinks, anything else for the made of unserviceable. Now for the tank, it should be checked for such things as dirt, rust, and water inside. Check the outside of the leak, dents, and damaged filler neck, and be sure the mountings are not loose. Well, you notice how much fuel the tank of them must have useful knowledge later. Look at it. Let's look up at the top of the tank, as you should give some of the attention. The thing you know that how much fuel is in the tank, the fuel gauge should show. If it does not, it could be sending unit is faulty. While you're looking, better check the electrical connection of the gasket and the mounting screws. Another item, the tank of the fuel pump. You should also check on it, or again, the electrical connection, gasket, mounting screws. Anything to check on for the pump is leaking fuel vent line connections. After checking line connection at the fuel pump, check the fuel line all the way to the carburetor and the vent line in the air cleaner. You should look for these such things as leaking connection, broken bent, and crimped leaking lines. So far, covered components from the tank filler cap of the carburetor. You should look for leaks, cracks, insecuring mountings, leaking gasket, loose missing screws. All right, next inspection. Inspecting linkage, control the operation with the carburetor, checking the accelerator linkage. You should look for missing, damage, improper connections, correction, incorrect adjustment on the choke linkage. You should follow the cable condition, cable stop, the cable adjustment. If you should move the choke with a full open, full closed position. Also check the cable operation, choke control mounting. When the engine is operating, the fuel will be flowing from the tank through the lines through the carburetor. A lot of the air must go through the air cleaner into the fuel system to operate properly, so that it must also be checked before you inspect the air cleaner. The cover must be removed. The things to look for are dirt and condition amount of oil, clogged wire mesh, holes in the oil reservoir. In addition, checking to see if the secure mounting of the condition of the air hose, close and clamps all fittings. Do not forget to check with the intake manifold. It is part of the air fuel system. Check with the intake manifold, gaskets, and leaks. Pour a small amount of the oil around the intake manifold flanges while the engine is running. If the oil is sucked into the manifold or the gaskets are leaking, loose manifold bolts will cause the gaskets to leak, so tighten them before blaming the gaskets. You should also look for excessive dirt on the manifold. Check with the cracked and warped manifold. Then it goes into a practice exercise with the answers, and then we move on to lesson 2, fundamental compression ignition engine fuel systems.